Welcome back students, this is your Chendu Gaud. In this video I am going to cover one of the very important and gunshot questions which is being asked in M1 course which you are taking the exam from the unit 2. The question is like this, like find the eigenvalues and the eigenvectors for a matrix 3, 2, 1, 4. You are supposed to work out the eigenvalues and eigenvectors for a 2 by 2 matrix or a 3 by 3 matrix or whichever the size of the matrix may be. So, if you look at the matrix size here, so this is of 2 by 2 matrix, dear students. Let us assume by working out this problem very neatly, let the matrix is A, that is all about 3, 2, 1 and 4. So, first what we are supposed to work out to the eigenvalues and the eigenvectors is to work out the characteristic equation. So, we know the value that for eigenvalue to work out the eigenvalues and eigenvectors, the formula A minus lambda into I equals to 0, where A is a given matrix and lambda is a scalar matrix and I is identity or unity matrix. Now, in the place of A, we are supposed to substitute the matrix A. So, that is 3, 2, 1 and 4 minus lambda into the matrix I matrix is of 1, 0, 0, 1. So, this equals to 0, why? Because it is all about 2 by 2 matrix. So, further we can write this matrix as 2, 3, 2, 1, 4 minus and multiplying this lambda with respect to this matrix. So, this becomes lambda and lambda times 0 is 0 and lambda times 0 is 0 and lambda times 1 is nothing but lambda and this is equals to 0. Now, we are supposed to reduce this equation by subtraction method. So, matrix subtraction is given as that this row minus and this row of the second matrix. So, 3 minus lambda. I have done addition, multiplication as well as the subtraction and how to work out the determinant of the matrix in this channel. Please go through it. So, 2 minus 0. So, this is 2 minus 0. So, 1 minus 0, 1 minus 0 and 4 minus lambda. 4 minus lambda, this equals to 0. So, this will become 3 minus lambda and 2 minus 0 is 2 and 1 minus 0 is 1 and 4 minus lambda will be 4 minus lambda, this equals to 0. This is our the matrix which we got from the matrix A by applying into this formula. Now, we are supposed to work out the determinant of matrix to work out the characteristic equation. How to work out the determinant of matrix, dear student? AD minus BC rule, isn't it? 3 minus lambda into 4 minus lambda minus of 1 into 2 equals to 0. So, this is all about the to work out the determinant of matrix. So, 3 fours 12. 3 minus lambda is equal to 3 lambda and minus lambda into 4 will be minus 4 lambda and minus of minus will become plus lambda square and minus of 1 into 2 will be minus 2, this equals to 0. Now, we are going to work out the quadratic equation from this. So, this is lambda square, later minus 3 lambda minus 4 lambda, that is minus 7 lambda and constant values 12 minus 2, that is all about plus 10 equals to 0. Now, we need to work out the factors for this 10. So, what are the factors for the 10? You can write here like 5 into 2 and 10 into 1. But whatever the factors you are going to multiply, the middle value whichever is here minus 7 lambda, when you add or subtract, that should give you that factor value. So, we can consider this as minus 5 minus 2 here. So, I can write here minus 5 lambda minus 2 lambda minus 5 minus 2, that gives you minus 7 plus 10 equals to 0. Isn't it, dear students? So, from this we can work out the factors. So, that is how lambda into lambda minus 5 and minus 2 of lambda minus 5 equals to 0. Isn't it? Lambda into lambda will give you lambda square and lambda minus 5 will be minus 5 lambda and minus 2 is taken common from this. So, minus 2 lambda and minus of minus will be plus 10. This is how we are supposed to work. So, what are the factors, dear students, here? Lambda minus 5 and lambda minus 2 equals to 0. So, hence lambda equals to 2 comma 5 are the eigen values for the given problem. So, these are nothing but the eigen values which we are found from the characteristic equation, isn't it? I mean lambda equals to 2 and lambda equals to 5 are said to be the eigenvalues for a given matrix of size 2 by 2. Now, we are supposed to work out the eigenvectors. How to work out the eigenvectors? We have a characteristic equation. It is given as A minus lambda I into x bar equals to 0. So, from this relation we can work out the eigenvectors. The similar procedure need to be followed if the matrix is of 3 by 3 or 4 by 4 also, dear students, to work out the eigenvalues and the eigenvectors. But whereas we have worked out A minus lambda I already here, so that is being reduced to this one. This is nothing but A minus lambda I. So, this is can be written as A minus lambda I can be written as 3 minus lambda, isn't it, 2 and 1 and 4 minus lambda into the x will become what, dear students, here x1 and x2 are the eigenvectors where we are going to work out the value for this. As it is a 2 by 2 matrix, we have x1 x2 to be taken into consideration. But for what is the value of lambda here to be substituted? I am taking for lambda equals to 2 to work out the eigenvectors first. So, I need to substitute in this matrix. So, upon substituting the lambda equals to 2 in the above matrix, so 3 minus 2 will be 1 and this is 2 and this becomes 1 and 4 minus and 2 in place of lambda will give me a 2 and this is nothing but the matrix of size 2 by 2 where value lambda equals to 2. Now, upon multiplication, so we are going to multiply the row followed by column, isn't it? So, 1 into x1 plus 2 into x2 equals to 0 is said to be equation 1 and the row followed by column, again you are going to get the same. Why? It is because of the matrix size and the elements in the matrix are also of same nature. So, let I write this is A equation and this is a B equation. Now, as both are same, what I am going to do here is either taking A or B. So, x1 plus 2x2 equals to 0. So, from this I can write x1 equals to minus 2x2, dear students. Now, assuming, let us assume or assume x2 or x1 equals to x1 or x2 equals to 1. So, this further reduces to what here? So, x1 equals to minus 2, isn't it, dear students? So, when I substitute this assuming x2 equals to 1, so my x1 will become what here? Minus 2. So, these are nothing but the eigenvectors for lambda value 2. The eigenvectors are found out to be what, dear students? x1 place what we got the value minus 2, in the place of x2 I got the value 1. You need to cross check whether this is correct or not by substituting any of the above equation. Let take minus 2 in place of x1, that becomes minus 2 plus and x2 is nothing but 1. We got minus 2 plus 2 into 1 will be what? Positive 2. Positive negative 2 upon calculation that founds to be 0. Hence, this is the correct way and correct answer for the lambda equal to 2, the eigenvectors. Now, we are supposed to work out for lambda equals to 5, what are the eigenvectors? Now, what I am going to do again here is, so in the same the matrix I am going to substitute the values, I mean the same matrix to be taken into consideration, 3 minus lambda, 2, 1 and 4 minus lambda into x1 and x2 equals to 0. Now, substituting lambda equal to 5, till here we got for lambda equal to 2. Now, we are working for lambda equal to 5, the eigenvectors, dear students. Hope you are catching my point. So, 3 minus lambda, in the place of lambda I am substituting 5. So, that will be minus 2, 2, 1 and 4 minus lambda will be minus 1 and this is all about x1, x2 and this equals to 0. So, this can be written as upon matrix multiplication, the row followed by column. So, minus 2x1 plus 2x2 equals to 0 is said to be equation A and row followed by column. So, x1 minus x2 equals to 0. This is a matrix, I mean the equation 2. Now, what you can do here is that I am further writing these two relations whichever we got here. So, that is all I got is minus 2x1 plus 2x2 equals to 0 is the equation A, and the equation B I got from the matrix is by substituting the lambda equal to 5, this is equation B. Now, I can write this as x1 equals to x2 from the equation B, and assume x1 equals to 1, assuming x1 equals to 1, and upon substituting here. So, what happens to the above relation? X2 is also equals to 1, dear students. So, from this we can found the eigenvectors for lambda equals to 5. The eigenvectors are found out to be what, dear students? 1 and 1. So, 1 and 1 are the eigenvectors for a value lambda equal to 1. To cross check this, substituting this is x1 and this is x2, substitute here, x1 is 1 and x2 is 1 of negative sign. So, 1 1 gets cancelled. So, that equals to 0. So, this is also said to be the correct value for lambda equal to 5, the eigenvectors. This is how you are supposed to work out the eigenvalues and the eigenvectors for a given matrix of the size 2 by 2, and if it is a 3 by 3, you are supposed to work out in a similar problem. First, what we have done, dear students, the matrix is taken into consideration. Later, you have worked out A minus lambda I and the reduce the matrix. Later, we have worked out to get the quadratic equation or the characteristic equation. The determinant of the matrix is worked out, and from that we worked out the factors, and from the factors we got the roots, and these roots are said to be the eigenvalues lambda equal to 2 and 5. Once the roots are known, we are going to work out the eigenvectors by using this formulae where A minus lambda is already worked out and x becomes x1 x2 for a 2 by 2 matrix. If it is a 3 by 3 matrix, x1 x2 x3, isn't it? For a lambda equal to 2, substituting in this matrix. So, you are going to get the reduced equations A and B, and assuming that x2 equals to 1 in this relation. So, x1 will be minus 2. So, similarly lambda equal to 5, you are going to work out this. This is how you are supposed to work out to get the eigenvectors and eigenvalues. Hope you are going to like my videos. Good luck and God bless you all. And do not forget to subscribe and share this channel with your friends.